Hi viewers, welcome to today's episode of Eulari Online Maths class. In today's video, we'll be talking about differentiation. What do we mean by differentiation? For English students, they'll be like, differentiation means difference between two things, or you'll be thinking as English student we do. But for the sake of mathematics, differentiation means a whole different thing. So let's see, what does that mean? So before talking about differentiation, let's remind ourselves, how do we say we calculate the slope or gradient of a straight line? Suppose we have a certain function y equals 2x plus 1. You all know that this is a straight line, right? Because you can see that the degree of the variable x here, which is the independent variable, is power 1. So since it's a power 1 degree of the independent variable, that means the graph is going to be a straight line graph. We have an addition of 1. That means it's starting from somewhere 1. It's going to be a straight line, right? So if you are told to calculate the graph of such a function, it's going to be a very easy task because you just cut a certain point here and here, right? You all know that this is a change in y and this is a change in x. Calculating this type of slope, you all know that slope is just change in y over what? Change in x. And you all know that we have a certain point of x here. Let's call it x naught. We have another point here. Let's call it x1, right? So for the change in x, it's going to be the x1 minus x naught. Then for the change in y, you can all see that we have a certain point. Let's make it this way. We have a certain point for y from here, right? So this is going to be like our y naught. This is going to be our y1 as well. So if you are to calculate this change in y, this sign that looks like d means change in y, which is same thing as y1 minus y0 over same thing for x, which is x1 minus x0, right? This is meant for just a straight line. How about when you have a slope? Introducing the concept of calculating the slope of, or should I say the gradient of a slope, is why we brought about differentiation. So how about when we have a function y equals x squared? You all know that from the independent variable x, you can see that it's power 2, which makes it a quadratic equation, right? And you all know that quadratic equation is going to have a curve, right? So it's going to be just a curve. So since we were able to form a certain point, to form a triangle here to calculate the slope, how about that of a curve? This one is going to be a bit hard, right? Because if I will just say I'll cut it like this, you can all see that this is not a straight line. I'm still having a curve, right? I'm going to have a curve. So that is where the problem came. How do we calculate this kind of slope? So they introduce what we call differentiation. And differentiation normally, without wasting much of our time, I'll just go straight to explain what it means, how to differentiate directly. And so for instance, for this one, for the y equals x squared, if you are told to find the function of the derivative, like a function such that if I differentiate this and substitute a certain value, because they said if you want to calculate the slope of a curve, the um, it's going to be the point at the tangent. Because recall that when I have a curve, any line that passes straight touching the curve is a tangent, right? So to calculate the slope of a curve is just calculating the slope of the tangent that touches the curve at that point of the curve. So for this very one, how do we differentiate this, then substitute a certain value to give us the slope of the curve at that point. So for this very one, it's just very easy. They say differentiate y equals x squared. You bring down the power. You can see the power is 2, right? So you bring down the power, bring back the variable x, then you remove 1 from the power. 2 minus 1 is 1. So the derivative of y equals x squared is what? 2x. So same thing for other functions. When you have, for instance, y equals x power 4, if you are told to differentiate this function, what you have to do is just bring down the power 4, bring back the function x, then remove 1 from the power 3. So as you can see, the derivative of x power 4 is 4x cubed. Continuously. So let's make a generality. Let's make it like when you have y equals x power n. I'm trying to say that n is a number, right? Because as you can see, I was having some powers of x. We had 2, we had 4, we had 3, right? Because you can still differentiate this. So I'm trying to say, okay, I want to differentiate a certain polynomial x raised to power a number n. So as you can see, I said you bring down the power. So, and recall from what I said here, we said slope of a straight line is just dy dx, right? So for this one, same thing. It's just the slope. You say dy dx is equals, bring down the power, which is n. We have n. Bring back the function x, remove 1 from the power, n minus 1. This is just the formula you'll be using to differentiate a certain function when given to you. So, for instance, if I will still say, let's take our y square again. Y equals x squared. If you compare this with this, you can see that our n is what? N is 2, right? So if you want to compare with the formula, you just to go straight and say dy dx equals n was 2. So you write 2, you write x. You can see that n is 2. So 2 minus 1 is 1. So we have power 1, which is equals what? 2x. So that's just how easy it is to differentiate. But one more thing is you can have, this is just for a single, like I just have x squared. I don't have plus another thing, right? So for instance, if I would say plus x again, then plus 1, it's looking more confusing. But mind you, this is still a quadratic equation. So if you are told to differentiate this type, don't panic. The only thing you do is just go straight and differentiate each of the terms one by one. What I mean is you differentiate x squared separately, you differentiate x, you differentiate 1. So one more thing I'll tell you guys is if you differentiate x alone, for instance, when you have y equals x, if you differentiate this function, you are going to have your dy over dx equals 1. If it were 2x, your answer is going to be 2. If you just have a certain polynomial attached to a constant, the derivative of that function is going to be the coefficient of the variable. But when you have, for instance, uh, y equals 1 now, you can see we don't have the variable there, right? So the derivative of 1, you all know that 1 is a number. So a number is a constant, isn't it? Because you can't change 1. Anywhere you see 1, 1 is always 1. So the derivative of a constant is always 0 because I don't have anything attached to it. If I would just say times 0x, everything, anything times 0 is what? 0. So our dy dx for a constant is always 0. So I think I've summarized what I need to summarize for you guys for now because we've spoke about how to differentiate a polynomial, even if we have some terms attached to it, either addition, subtraction, or what of you. So since I've taught you guys how to do differentiation of this kind of function, how about when we have two functions being product of each other? For instance, that's when we have y equals some function of x, which is u, and v. You can see that two functions are product of themselves here, right? How about when you have functions being quotient of each other? There are so many functions that are confusing to differentiate. So I forgot to mention earlier because there are, so differentiating a function depends on the kind of function you are differentiating because we have exponential function, we have logarithmic function, we have polynomials, we have trigonometry, and so on. So I will be making videos on each of these functions and explaining how to differentiate each of them because we have so many rules for differentiation. We have the chain rule, we have the product rule, we have the quotient rule. So if you miss out the coming videos, you are going to miss a lot because this is not all about differentiation. This is just an introduction to the differentiation. So don't miss out the next video. And please, if you really enjoyed this video, you should do well by subscribing, commenting, liking, and sharing. Thank you.